So for the oblique asymptote, we'll have to perform division, actual division, x squared minus 4 divided by x plus 4. So this will entail you to review how you divide polynomials, basically. So we'll have x squared minus 4 divided by x plus 4. Remember that for us to do so, make sure that the missing terms are still presented. So division, x squared divided by x is x, then x is multiplied to x plus 4. Then just as we do with division, we subtract these terms. Now we end up with negative 4x minus 4, to which is we divide negative 4x and x with negative 4 times x plus 4, of course, gives us negative 4x minus 16. We subtract the terms again, so we have 12. And since we do not have any other term left, that brings us to a remainder. 12 over x plus 4 with x minus 4. We have x minus 4 as the oblique asymptote. So we just have to make sure we know how to graph an x minus 4. So following the sample points earlier, we get this is x minus 4, by the way, the oblique asymptote. This was the vertical asymptote earlier. Then we'll cover by using these ones. And you'll see how the graph behaves. Of course, if it's better if you cover more points. Just choose values which will make it easier for you to graph. Now, of course, rational functions are used in a lot of situations. I've shown you some functions when we started discussing functions. So here's one. Here, I think Ed presented this as well before. 40 over t squared plus 2 is a function that represents the concentration for the drug in the patient's bloodstream. Then, if we are to make use of this function, it goes by this question. How much of a medicine is still in the patient's bloodstream after some time? In this case, 40 minutes. Take note, that's 40 minutes. T was described earlier as in terms of hours. So we'll have to convert 40 minutes into hours, which is 2/3 hours, which gives us 1.090 milligrams per liter. So there's still medicine in the bloodstream by this much, depending on the um, nurse's, what is it? Depending on how a nurse or how a doctor interprets this time, it would mean they'll be soon they'll be giving the next dose of the medicine. Next is this one. You're in the ABM strand, so you'll be getting a hold of this function in the very near future. This is a model for average cost, which is the quotient of fixed cost and the cost of each output divided by the outputs produced. So here's the situation, and here's the answer to the situation. Here's another one. Very simple looking function. Input divided by output. That ends our discussion on rational equations, inequalities, and functions. I'll be emailing you your task after viewing these videos and more videos to come.